All right, so last week we talked about 3D printing something, and I said that for today I'd like you to have some sort of design or concept. So if you have that, I want to look at that today. Otherwise, or even without it, I want to go over the process of how you then take something like that and actually build it in 3D so that it can be printed. Okay, so this is where we'd actually be building something to scale. So I'm going to use this item here. So I found out that this is actually like an extra one that printed somehow. So I'm going to use this as my example. Now, if I had the original file, I could just open up the original file and base it off of that. I don't have the original file on me, so I'm just going to use this. Okay. So what I'm going to do is create a base for this, and the concept is it would sit like this, and then I would have in the center of this one, I would have a hole, and so that I could put my item on top of that and a light would shine in the hole and then light up this entire thing. So I thought that would be cool to do. So that's what I need to do, is figure out how big this base is, and I need to translate that information into Maya. Okay, so this is a ruler if you're not familiar with it. Inches are on both sides. Maya right now is in centimeters, so if you're not familiar with it, inches can go into centimeters. So I'm just going to measure how big this square is, and it is like 3.5 ish. Okay, it doesn't have to be exact with this one. If it was, sorry, 2.5, then I would have to make sure that I'm more exact than I'm being. Okay, it's actually 2 3/8 is what I'm looking at. 2 3/8, that looks good. Okay, so I need to translate that information into Maya. Now, just so you can see it, if I go to the little running man in the bottom corner and I go to settings, there is a spot to change what I'm doing from centimeters to millimeters to inches to whatever. It doesn't matter. Keep it in one unit. I find centimeters is pretty good. The fact that this is in inches is not a huge deal. Actually, centimeters is on the other side, is it? Nope, that's still inches. I will convert that anyway to centimeters. All right. So, 2 inches to centimeters, Google is wonderful for this, is 5.08. And you could even do like 3/8, because that's what it is. And it would say that it's 6.0325 centimeters. Now that 0.325 may not sound like a lot to you, but when you're trying to create something pretty exact, it is something, okay? This was another item that I modeled before. This is what I talked about when we did our photo shoot. This would clip onto the leg of a tripod, and then you could pull it off, and then when you need to unscrew the little adapter for the mount, you could use that side for it, and then you just clip it back on. So that was something that obviously it has to be exact, because I needed this to snap onto the leg. If it was too big, it would just slide right down. If it's too small, it wouldn't fit. And the same thing with this little slot here, that had to be wide enough to fit that opening, but obviously not too wide or not too small that it would break when it turned. All right, so 6.0325. So I'm going to go to Maya. I'm going to go to create a cube. And what I like to do is just create a basic rough structure of what my object's going to look like. So in this case, 6.0325. All right, so looking at this cube right now, this cube is basically 1 centimeter by 1 centimeter by 1 centimeter. I know that because if I look at my grid units, it would basically fit right inside of one of these grids, like that. Okay? So if I go over here and I go to my scale and type in 6.0325, boom. It does look like it's rounding it here, but it actually is keeping the 2.5. Sweet, that's good. Oops, I moved my pivot. I want to reset that. 6.025. There we go. All right, so now I can set this on the ground. So this is roughly this bottom piece. That's what that is. Because what I want to do is create some sort of platform that I could just set this on. And so I need to have some sort of shape that could fit that. That's all that shape is. It's just a stand-in shape. So now what I can do is, now that I know how big that shape is, now I can start to design what my platform is going to look like. Now remember, this is centimeters, not inches. When I go to create an object, let's say I create a cylinder. So something like that. I'm just going to move this whole structure up. I'm going to take the caps off of here. I'm going to go to this face. I'm going to extrude it. I'm going to scale it in like that. Okay. And I'm going to square this off. So I'm going to grab these points here, go to my scale, and scale this in. Go to these points here, and scale those in. Go to these points. And you get the idea of what I'm going to do with this side. So I like to build everything just like I would model it in for a game or for a movie or whatever I'm doing it for. Just very rough first, and then start to add in the details. Okay? If you try to go too detailed right away, then you're just going to lose what you're trying to do. Okay. That. All right. So looking at this, now you can see if I just isolate this, now I have that square. That's where my object would sit. Now I also have to consider in this specific thing, is it going to sit flush with it, or is it going to be like recessed, right? So let's pretend that I'm going to go crazy with this, and I'm going to make something that's this deep that I want this to sit in, right? So then this bottom area is no longer the smallest dimension. This area here would be, and I'd have to account for that. I'm just going to have it kind of sit on there so that it's pretty flush. So that's what that thing is for there. But what I mean when I'm talking about it being flush is that I can't take this here and pull this up, because then no longer would my shape be able to fit inside here, because now it would be like floating inside of it, okay, because of the angle of those sides. So I am going to give this just a little bit of a recess, just like that, just so it has something to kind of click in. I'm going to extrude it again and bring it into here. And then I'm going to go to Shift right click, and then I'm going to go to Circularize Component. Okay, and this makes a perfect circle right in the center of our shape. If I'm going to add a light bulb to this, right, so I want to have a light bulb sticking out of that, that is an easy way for me to take that shape and then add a hole right there. So I'm going to extrude that and push it in some, and then delete. Now this is where other measurements would come in handy. So if I'm going to add an actual light bulb to this, I need to know what kind of light bulb am I going to use? How big is the light bulb? How is it going to fit? How is it going to connect? So mentally I have this all kind of prepared that inside the base here, which is going to be a bit thicker, so like that, let's say, I will fit one of those, what are they called, watch batteries, and then I will connect some wires to some LEDs, and then I could just stick the wires with the LEDs up in there, and then I'll create some sort of switch on, switch off device. Okay, so it's all going to be kind of like self-contained inside this bottom thing. I could do the same thing here, but then I have to fit watch batteries inside here, and I have to fit LEDs inside there, and that's just too much work for what I want to show. All right, so how big is this opening? Now that I've created this, how big is this actual opening? If I go to Create Measure Tools and I go to the Distance tool, I can click on, I'm going to go to the top view so I can see this. I'm going to hold down V and click on, actually I'll just click. I'm just click this point here, and I'm going to click that point there. There we go. So this is 2.26 centimeters wide, okay? So does anyone know how big 2.26 centimeters is in inches? It's about an inch, okay? We go back to here, 2.26. See, it's almost an inch, right? So that is, if I look at this, that hole is like that big. I need to know this stuff, because if I'm going to put a tiny LED right there, I need to know that that's like crazy big for this thing to be. The LEDs that I have are probably about a 1/4 inch. Okay, so that's as small as I want to get, as a 1/4 inch for that width. So I jump back to this. Well, I should probably jump back to this and see what is a 1/4 inch, 0.635 centimeters. And then what I'm going to do is, whenever you do a distance, you get two locators, and then between them is the distance. Okay, So I have my outliner open here. Here's my two locators. I'm going to Control G to group them together, and then go to my scale and just start to scale them in. And what I can do is I'll scale them until I get it to about 0.635. Okay, I'll actually stop maybe about there. There we go. That should be good. I have plenty of room to kind of fit the LED through and put like maybe a little bit of glue or adhesive or something just to kind of hold it in place. All right, so that's how big that circle needs to be. So now I can go to this face, if I can grab it. Oh, I deleted it. I can go to these edges, or the face. Come on. Nope. There we go. And then I'm just going to scale it down until it fits. There we go. So that should be good there. So you can see the huge difference in what I had a second ago. The hole was basically this big, and I'm trying to fit this tiny light bulb in it. Makes sense? So now I have a tiny hole that's going to fit pretty close to what I need. Cool. So there's that. Now, like I said, I need a spot so that I could actually stick a light bulb and watch battery through this side. So I'm going to extrude this and scale it down. And I'll extrude this again. Push that up some. And then I'll delete that. Okay, so now I have somewhere that I can see very easily if I have this stuff. I have the item flipped over. I put the watch batteries in. I connect the wires to the LED, and it works. I can connect all my stuff. And then on the bottom of this, I can basically just put a whatever. Okay, if I have something else that I want, I can just stick it over the bottom, just like a sticker, so it matches. Or what I can do, I'm going to duplicate this, and I'm going to delete everything but this ring of faces. Okay, so I just have that ring of faces right there. And then I'm going to take this part of that ring. Nope. Yes. Yes. I'm going to take this ring, there we go, the whole ring, and I'm going to extrude it inward a little bit. And then I'm going to extrude this outward. And then, is that what I want to do? That's not what I want to do. Hold on. I'm going to take this ring, yes. Extrude it outward, like that. Perfect. That's what I wanted to do. Okay. So now this will fit snugly right there. I just need that to fit here, like that. Good. And then I'll take this ring here and extrude it and bring it in. All right, I'll close it off in a second. Okay. So now I can't, even this piece here I'll talk about in a second, but I can't print this. This item has no actual thickness to it, so if I tried to print this, it would basically print like a flat piece that would just fall apart, okay? It has to have some sort of actual thickness to it, and it has to be what's called watertight, meaning that there's no holes in it. If there's a hole in it, it'll actually fill the entire hole like it's a solid shape, okay? So I need to add thickness to this. I'll do that in a second. So I'm going to grab this. I'm going to shift right click and do my merge vertices to center. That closes that off. Now I need to give this whole thing thickness. Now I can't give it thickness this way and that way because that would protrude into my actual bottom piece. I have to go the other way and give it thickness coming up and in like that. So I'm going to extrude this, and there is a thickness slider right here. So you can just type in like 0.25. There we go. And that worked. It went the correct direction. If it went the other direction, 0.2, it would go the opposite way, and then it wouldn't fit my shape the exact way I need it to fit. So 0.2, 0.1, 0.125, there we go. Cool. So now if I look at this piece as I move it down, okay, you can see right here where the edge of this is. My new surface, my new bottom peg has to slide in right aligned with that. Maybe just a tad of room, just so I have something to play with. but it has to be close. Okay, so that's what I'm checking here. All right, so now that lines up perfectly with it, which is where I kind of want it, but not really. I need it just a little bit in. If it's right on, it probably wouldn't work perfect as much as I want. So I'm going to go to my center pivot, and I'm just going to scale it down slightly. Now I want to scale it down uniformly. All my scales are kind of crazy numbers, so if I just modify and then freeze my transforms, then I can just type in something really simple like 0.99. That might have been a bit too much. Yep, that's a bit too much. 0.99. There we go. All right, so you see that tiny distance there. That tiny distance may be just enough for me to get it into that without it doing anything weird. Now, if it isn't enough, I could always get at the Home Depot store, they sell these like big rubber elastic washers, or you can get a rubber band, and I can just put that around it. That way it has something to grip onto when it goes in. Okay? The more elaborate your design, the more things you have to think about going into it. All right, so that gives this piece thickness, and it makes it a legit surface to print. So that one's cool. There's watertight, it's fully sealed. This one here is not watertight yet. It has to be watertight. So I'm going to do the exact same thing. I'm going to go to Extrude. Now this one is going to be a little bit trickier. I can't give any more thickness this way. Okay, I can't take these edges and push them in more, because then that will not make my cap fit on there nicely. If I go outward with it, what I'll probably find is that it makes this a little bit skinnier, which means I'll have to go back and just adjust that. Okay, so just stuff that I have to be aware of if I'm fitting pieces together. So I'll type in 0.2. Oops, did that go the right way? Let's hit undo. Yes. No. All right, that did not go the right way. Let me do that again. Extrude. Negative 0.125. There we go. So now that went the right way. So that went inside. Cool. And then here's where my light is. Yep, and my light diameter didn't change. And the diameter of... Oops. That didn't change. Okay. It's inside out, so I'm going to go to Mesh Display Reverse. So now this one has thickness. It's perfect. And then this one has thickness. That's perfect. And then both of these items, if I were to send them to the printer right now, they would print, right? Now I want to take care of some other things because it'll print exactly like we're seeing it. So what that means is if I go to my top view, you see how... change my background color. It's always something. See how chunky that is? It'll print ugly chunky like that, and we don't want it ugly chunky. I want this nice and smooth. The other thing is if you have a completely sharp surface like this, it will print. There's no problem with that, but I found that it's actually easier to remove the support material when you don't have sharp edges like that. Or if you have just a little bit of a bevel there, it makes it easier to peel off the stuff. You'll see what I'm talking about when we go and actually tour the print room. All right, so I'm going to put bevels on everything that has a sharp edge. Bevel, 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 bevel. Whoopsie, not that. All right, so that looks like all the sharp edges. So now I go to bevel. I'll do 2 segments here. And it looks good. Just a slight bevel, that's all I need. Okay. Now look at this too. When I hit 3, see how we're getting rounded corners here? So because I don't have extra divisions there, it's rounding off those corners. That could be an issue, because I could go to set this thing in there, and now one of these corners that used to fit perfectly has now been rounded, and now my thing won't fit inside that hole. So again, stuff that you have to consider. I may need to hit undo on my bevels. I'm watching down here until it says undo bevel. Wow, I clicked that a lot. There we go. So I may need to come in here and just shift click each one of these corners and add a bevel in there too. So close to select. There we go. All right, so now when I hit 3, you'll see that we have sharp corners right there, and that is perfect. Okay, so that's good. Let me go to this piece, and I'll do the same thing. I'm going to go to edge, 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 edge. Bevel, 2 segments. Okay, I hit 3 just to make sure it looks good. It does. Okay. Now, when I hit 3, remember that's a preview of what it's going to look like smooth. When I send it to the printer, it's going to do the exact same thing of being chunky. So I actually have to go up and say mesh smooth. I am paranoid about doing that, so I always duplicate first. And I'll scoot that one over, or I'll throw it on a layer and hide it. Either way works. Mesh smooth. Cool. That works. You could literally take these divisions up to like astronomical volumes, like 2 and 2 or 5 and 5, however smooth you want that to be. All right, so that looks like that will work. Okay. Now before I go to the next step, I just want to double check all my stuff. So I have my cube, which I have soloed. Let me unsolo the cube. I want to double check that it fits. Oops. If I go to wireframe, there we go, then I can see it. Yep, the cube still fits right in there. I want to double check that this still fits, so I go into my front view. I pull it up here. Yep, still fits good. That's good. Okay. So everything should be good now. Both of my pieces fit. My diameter didn't change for the LED. I'm just going to take the distance thing off, delete the group. Okay, so now I'm going to get this ready to print. So I'm going to delete my history. I'm going to freeze my transforms. And then I'm going to set this up as how I would want it to print. When I print something, what's going to happen, a printer like this one here, it basically will print like layers, okay? So imagine that you're printing something on a regular piece of paper, it's just one layer. But then it would come back and do another layer on top and another layer on top. If it's something like a box, that's not an issue because it prints the bottom layer of the box and then it gradually moves up the side of the box, right? That makes sense. It just stacks stuff on top of it like Legos. When something is turned, though, what has to happen is on this printer, it prints this very bottom corner, and then the next level has to support or be supported by the level below it, okay? So it would basically try to print the next level supporting it like that, and then the next level supporting it, the next level supporting it. So a printer like this is good for some stuff, but not for advanced stuff, okay? That's why it's only $500 versus $500,000 or whatever they are. The ones that are more expensive, when I'm printing something like this, it does 2 prints. One of them is support material. So it prints this black material all around it that supports all these sides. And it's literally just like a cage that holds up these things so that as it prints the actual plasticky material, it has something that will hold that up, okay? And then what we do is we can either, once it's done, we can break off the support material. That's ideal case. For something like this, we couldn't just break it off because there were so many little crevices that it printed that stuff in that it was basically wedged in there, and we had to throw it into this chemical bath, which basically dissolves all the black stuff and keeps this intact, okay? Something like these guys here, if I were to have printed them like that, it would have printed support material all inside the center of this cavity, and then possibly up inside that area. I printed it like this, though, so that it's perfectly flat. So all it has to do is print straight up, and that's it. That way, when I was done, I popped them off, and they were done. Okay, there's no chemicals. The cleaning process for some of these can take hours. Sometimes they can take days, depending on how much support material there is. Okay, I've tried even, and I've cut my hand a few times, breaking off the stuff with like a Sharpie, an X-Acto knife, or a pair of pliers, and it's sharp, and it will cut you, and it's horrible. So how you set this thing up to print will make it easier for you to take it out later. So for something like this, I want the biggest surface area to be on the bottom. So I'm going to take this and flip it upside down. Like that. Okay? That way I have a big hole right here. It'll probably fill that hole with support material, but that's fine because it'll have a nice lip on the top to hold that stuff. Alright, so that's good. And then this piece here, I'm going to take that and just scoot that over. And this one doesn't really matter. I think it'll print pretty much the same way either way. So that one's going to be fine. So I'm going to go to my front view here, and I'm just going to line this up with the ground. I'm going to use D key to hold down for the pivot, V key for point, and move this pivot down to the bottom. And I'm going to let go of those and just hold X and snap this vertically to the ground. That way it's sitting right on the ground. Again, thinking about how much time you want it to take printing is an important step. Oops. So D and V to move the pivot, and what that does is snap it right to those vertices, and then X snaps it right to the grid. Cool. All right, so there's my two pieces. I'm going to freeze transform again on this. Oops, let me move it centered. Not that that matters, but I'm going to put it there anyway. Freeze transform. Delete my history. I should probably have made a project at some point. That's how confident I am in my modeling skills. 3D print folder 4. All right. I don't know why it always jumps to these random folders. Here, nope. There. So I'm going to put this in my scenes right there. Okay. And then the next step, I'll go ahead and do the printing stuff. Now, before I even get into that, just some things to kind of talk about too. With this kind of thing, obviously the sky's the limit, literally. Like, you could build anything, you could model anything. We have a 10 by 10 platform. We have to minimize our print times to like 4 hours apart. So we do have some limitations here at the college, but you could make anything with this kind of stuff. One thing I could do is I could actually come into these kinds of areas here, do some more extrusions, and then actually add like LEDs around the thing too. That's another thing that I could do to this. I could even grab the text tool and I could put my name right along there if I wanted to. Right? There's nothing limiting me to what I do. If I can model it in 3D, I can add it to this shape. Now, when you get into stuff that's a bit more advanced than that, you have to do other things. So just for fun, oops, let me grab a sphere. Okay, so let's say for fun, I wanted this little ball right here. And just for OCD's sake, I'm going to center this a little bit better than I am. There we go. Okay. So let's say I wanted this ball to be printed right there. You'll see that the ball is going inside the shape too. So the 3D software would actually interpret that as something else that needs to print. And so it actually would print the ball on the inside and outside of it. So if it's something simple like this, I could go through and actually just delete the part that's sticking underneath, and that shouldn't be too much of an issue, okay? But most of the time, it's not something super simple. The other way we would do that, and this is the only time we would ever really use this, is if we booleans it, and I did a union. And so what booleans is going to do is it's going to find these two shapes, find out where they're intersecting, and delete anything that's on the inside of it. Boom, okay? So now if I look on the inside, oh, come on. Oh, it did. It did do it. Look, see, it did it right here in the center, just not on the other side. I would have done this before I did my thickness. There's always a timing element here that I apparently am neglecting. Let me just delete the stuff here. Then we can do that again. Not look like an idiot. Or try not to anyway. I'm going to go here to there, delete. I'm going to do the same thing over here. Here. Delete. All right, let's try that again. So these two items, mesh, booleans, union, burp. There we go. So now we cut it off. And then now I would do my extrude and push it in, okay? Now, if I do something like this, look at how messy the geometry is. See how we have this edge here that doesn't really go anywhere, it just stops? Maya hates that. If I brought this into Unreal, that would hate it. If I brought it into ZBrush, that would hate it. If I brought it into Substance, that would hate it, okay? So most programs do not like it. Now, the way we can get around this is because we are not going to model this outside of this program. We're not going to touch it outside this program except for to print it. So if I just go to Mesh Triangulate, boom, it fixes all those things. Now it creates this ugly, hideous piece of geometry here, but it's printable, okay? It can work in the print area because of that. But we don't want to look at that. Cool. All right, so now there's my two shapes. I'm ready to print it. So I go to File, and Maya actually has a Send to Print Studio. On these computers, I don't think it's installed yet. You would go to, just like I'm doing here, you would go to Download. And then you would download the Print Studio, and then this would be the area where we would save it out as an actual file. Yes, yes, yes. That would allow us to print it. And what it's going to do is it's going to take these two parts, bring them into a virtual 3D print world where we can see where the parts would be laid out on the machine. Make sure they're centered, make sure they're sized. Yep, yep, yep. Yes. Oh, I accept that. Yep. And then install it. And then we can kind of position things. We can rotate things. The step after that is that we would go to the print room, which is down the hall and around the corner, and then we would print these up. Now, my goal is that I'm going to throw this one on a jump drive, and then if you want to, whoever wants to, we can go down to the print room and I'll show you how it actually prints. Obviously, you're not going to watch the entire thing. This piece may take 4 hours to print the entire thing. I don't want you standing there for 4 hours staring at a machine. Finish. Yes. Sure. Yep. Yes. And yes. Cool. All right. So now if I go to Send to Print Studio, it should open up Print Studio after I accept this one also. All right. It wants to know what kind of printer I'm using. So typically, if I have a printer connected to my station, I could print right to it from this software. There are services online, so if you do print something that you're like, cool, I want to get an actual like full-blown model of this, you can send them to print services and get your stuff printed for a fee. Or you can say, plug it in now, connect your network. Print later. I don't think I've ever typed this one before. Just hit OK. Just plug it in now. Connect. Prepare. There you go. I'm just going to prepare to send it to a print service, and I'll just export it. That'll work. OK. So here are my objects. Of course, why would Autodesk have anything the same as every other program? Your moving and rotating and everything is all screwed up again. My right click is spinning around for whatever reason. My middle click is to move, and then my scroll wheel is zooming in and out. Okay. So it looks like it's under the grid. It totally is under the grid. I need to go to Layout. I need to go to my Move, and I need to say to Move to Build Surface. There we go. So now it's actually on the build surface. This layout gives you an idea of how big it actually would be as it printed. So if this is a 10-inch by 10-inch thing, it'll pretty much be just right in the center. And if we looked at how big this was, I mean, it's not going to be much bigger than this, like probably about like that. So now I can just export this out. So I'm going to go to File, Export Selected. I'll just throw this onto my desktop for now. Sarcona base. All right, the file format it uses is an STL. The software that we're going to open this up on reads STL files. That's what we need to do, just like when we go to Substance or Unreal or anything. So I save it. There it is. So there's my file. Now, I always want to wait a few minutes before I copy it. Not that the walk is long, but it's too long for me to walk down there and try to load my file, and then it says, nope, you don't have a complete file. And that's happened several times. So this is a 7 megabyte file. So I'm just going to hit refresh, make sure it still says 7 megabytes. Yes, cool. And I'm going to throw it onto my jump drive, or a jump drive that's over here. There we go. Sweet. So here's my base print. This is 7 megabytes. The holocron, this thing plus all the little corners, was 2 megabytes. That means I overmodeled the stuff.